Okay, we have one more discussion, one more thing to learn and talk about when it comes to exponents. So having exponents to a fraction. Remember that negative exponents make a fraction, but a fractional exponent is a little bit different. So if you'll look up here, you'll notice that taking a number to the 1/2 power is the same as, hope you noticed, the square root. So 4 to the 1/2 power is the same as square root of 4. And this doesn't really, it's probably not going to make you really happy because I don't, kind of bothers me, but the logic is that if I have 4 to the 1/2 power times 4 to the 1/2 power, that's the same as 4 1/2 plus 1/2, which is the same as 4 to the 1, which is the same as 4. So if 4 to the first power is 4, 4 to the 1/2 is going to be the square root of 4. So just think about when you see, just like I told you, when you see a negative exponent, you should be thinking fractions. I'll just go ahead and write all that down. A fraction, you need to be thinking roots, not necessarily square roots, but in this case, it's the square root of x. And you're going to get into these more later in Algebra 2, maybe geometry, but I just want to, we're just introducing it. We're kind of looking at in general what happens. And we will not really worry about it after that. Okay, I'm done rambling. Okay, so if it's raised to the 3rd power, to the 1/3 power, that means we're taking the cube root. And you write it, you put the little 3 right here. So that's your root. When it's not there, like this, okay, it's a 2. This is always square, but you could also put the 2 in there. Okay, so if I have 27 to the 1/3, it's the same as 27 with the little 3. Don't forget that because that tells you what you're doing. Okay, so number 5, we're going to simplify this expression. And remember, one thing we do is we distribute that 1/3 to everything. So the first thing I'm going to do is, can't remember if I was going to talk about this before. Okay, we have 27 to the 1/3. We have x cubed to the 1/3. And we have y6 to the 1/3. So remember, when you have a power to a power, you multiply. So I end up with cube root of 27, because I'm going to simplify that. So I have x to the 3rd power times 1/3. I end up with x's to the 3/3 and y to the 6/3. The cube root of 27 is 3, because 3 times 3 times 3 is 27. So I end up with a 3. X to the 3/3 is x to the 1, and y to the 6/3 is y squared. So what I did basically was I multiplied my fractional exponent times the exponent I already had, and when it was a number and it could be easily simplified, I simplified it. So let's look at number 6. Okay, it's to the 1/2 power, so I can write 125 to the 1/2 power and x cubed to the 1/2 power. So I end up with square root of 125 and the square root of x to the 3rd, and I can write it like this because that's squared, and neither one of those is a perfect square, so I'm just going to leave it like that. We could simplify it and take some of it out of the radical sign, and we'll do that when we're factoring, but for right now we're just going to leave it like that. So it could be written either way. You could write 125 to the 1/2. And the x, you can multiply 3 times 1/2 and get 3 over 2. That's also the same thing. Notice that the 2 on the bottom is my square root, and the 3 on top is what ended up here under my square root sign. So I'm just multiplying with fractions for the most part. Number 7, I'm going to get rid of this 2 here and this 1/4 here, and then I'm going to combine. So if I have x squared squared, I have x to the 4th, y squared, and my y, I have 4 to the 1/4, which is divided by 4. So I have x to the 4th, y squared, y to the 1 power. So I have x to the 4th, y cubed. Number 8 is not going to be pretty, but we'll see how far we can get. So I have 16 to the 1/4, x to the 8th divided by 4, and x to the 6th divided by 4. So I know that 16, the 4th root of 16 is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So I end up with a 2. My x to the 8 over 4, 8 divided by 4 is 2. And my x on the bottom is not going to come out even, but I can simplify to 3 over 2. So I could leave it like that. I could subtract my x's, and I end up with 2 x minus x squared minus 3 halves. So it's 4 halves minus 3 halves, which is x to the 1/2. I can write it like that. I could leave my square root on the bottom, and I could write 2x squared. It's a square root of x cubed. So both of these are correct. And at this point, it doesn't really matter which way we leave it. I guess this one is a little more simplified. But like I said, we're not going to get into this really like big, deep, heavy, important, because we're just kind of looking at it, seeing different ways we can write the same thing, and understanding that when we see a fraction, we're thinking square roots or roots. So let's do number 9. I'm going to multiply everything times 6. So I have 2 to the 6th, x to the 6 over 2, y to the 6 over 2, c to the 6 over 3. I multiplied everything times that exponent 6. And then on the bottom I have x, y, z to the 4th. 2 to the 6. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So I have 64, x squared, y squared. No, I don't. I have x to the 3rd, y to the 3rd, z squared over x, y, z to the 4th. So I end up with, excuse me, 64. I have x to the 3rd minus the x on the bottom, I have x squared. Y to the 3rd minus a y on the bottom is y squared. Z squared minus z to the 4th, I have z to the -2. I could write it that way. I could write 64 x squared y squared over z squared. Also the same thing. Okay, number 10. I'm going to change colors just so you can see it. Okay, so I have the square root of 48, x to the 4 over 2, y to the 3 over 2, z to the 5 over 2. Square root of 48 is not a whole number, so I'm actually going to just leave square root of 48. X squared, y to the 3 over 2, and z to the 5 over 2. I'm just going to leave those improper fractions as improper fractions because we're not really going to do a lot of simplifying right now. I could write them as square roots. I could write everything as a square root, but there's not really a reason to, and I guess the important thing to notice was x to the fourth was the only one that simplified nicely. So when you have some improper fractions like this, I would just leave them as improper fractions. Okay, so of course now we're talking about things that don't really fit for linear, which is where we're going with all this. So if I'm looking for the number of calories that a dog needs each day, and I'm a super duper calculator person because I love my calculator, then I can put in my calculator 16 and use the little caret and put 3 divided by 4, and I get 8. So C equals 72 times 8, which is 576 calories. That's how many calories that dog needs. Okay, so I just put this into my calculator by putting in 16, a little caret thing, 3 divided by 4. Okay, like I said, don't get all, worried about this. We're just looking at it. Oh, hey, let's go back up to the top. This is what I want you to think about. Okay. When you see a negative exponent, you should be thinking fractions. When you see a fractional exponent, you should be thinking roots, square root, cube root, whatever it is. So those are just things you need to be comfortable looking at and seeing, but you don't have to know the answer all the time to every single little bit of them. Shoo, bye. Oh, I did it again. I hate it when I do that. I hide it instead of stopping. Stop. Wow, I give up. It says it's still